Okay, in 5.2 day 2, we're going to extend our properties a little bit further. If we take our function and we substitute any value for x, we'll get a result. So that means that the domain, which is x values, is all real numbers. So that's because it opens up or down, and any value of x can be substituted in and we'll get another real number. When my function or my parabola opens up, we then have a vertex which is a minimum. So an open up has a minimum value. The domain, again, will be all real numbers, but the range will be from that minimum on up. And remember that k also equals the function evaluated at the opposite of b over 2a, if it's in standard form. Then if it opens down, we have a maximum value. Domain again is going to be all real numbers. This time the range is going to be all y values less than k, remembering that k again is the function evaluated at the opposite of b over 2a. So let's try that. We have a function in standard form. A is 2, b is negative 2, c is 5. First we determine if it has a min or a max. A is positive, so it opens up, so it has a minimum. The x value of the vertex is the opposite of b over 2a, so that is the opposite of negative 2 over 2 times 2, which is 1/2. We find the y value of that, so we evaluate function at 1/2. So that's 2 times 1/2 squared minus 2 times 1/2 plus 5. 1/2 squared is 1/4. 2 times 1/2 is 1. So that's 1/2 minus 2 halves plus 10 halves, which is 9 halves. So the domain, write that down here, the domain is all real numbers, and the range would be y such that y is greater than or equal to 9 halves, or 4.5, whichever you decide to do. How can you tell from its equation whether a quadratic function has a minimum or a maximum? So if a is positive, it has a minimum. And if a is negative, it has a maximum, because that means it opens downward. How can you use the min and max value of the quadratic function to find the range? It'll be all values greater than the min, or less than the max. So we're going to try this again. Find the min and max value for each function. State the domain and range. Okay, so the first thing you want to do is find the opposite of b over 2a. So a equals 1 equals -6, c equals 3. So the opposite of b over 2a is 6 over 2, which is 3. A is positive, so we do have a min. And then we evaluate the function at 3. So the domain is all real numbers, and the range is y such that y is greater than or equal to -6. So you try the next one. I'll give you a hint. A is -2, b equals 0, c -4. Because you have a max this time, your A is negative, your range has to be less than. Okay, we're going to do some applications. Is this a maximum power? At how many revolutions per minute must the engine be operating to achieve this? Okay, so the maximum power, and again, this is negative, so it opens downward, so we do have a max. So we need to find the opposite of b over 2a. And when you solve that, you get 6,122. And that answers the first question. The second question then is to find P at that number. And if you solve that, you get 300. So the max is 300 horsepower 6,122 RPMs. Okay, doing the next one. Again, the maximum mileage for this compact car to the nearest tenth mile per gallon, and what is the speed? So, miles per gallon. First thing we need to do is find the opposite of B. Over 2A. Which gives you 49. And then evaluate the function at that. And you end up with an answer of 30. So the max is 30 miles per gallon at 49 miles per hour. Okay, so we're going to close out the lesson. We're going to look at each of these two forms, find the y-intercept. Remember, the y-intercept in standard form is c. So c equals 6, so the y-intercept is 6. On this one, you substitute 0 in for x, and you get 6. Axis of symmetry is the opposite of b over 2a, which is opposite of negative 4 over 2 times 2, which is 1. H in this case is 1, so this is x equals 1. The vertex is then substituting that value back in. One times 1 is 1, times 2 is 2, minus 4 is negative 2, which is 4. So the vertex would be 1, 4. The vertex here is HK, which is 1, 4. Maximum or minimum value, A is positive. So there is no max. It has a min. That would be both cases. A over here is positive. It's 2, and over here it's 2. So the minimum value would be y equals 4, and it's the same thing over here. If I was going to write that as domain and range, it would be the range y such that y is greater than or equal to 4. And this ends day 2.